All right. Hello, everyone, and welcome on board to another webinar from Endress+Hauser, Australia. We're very happy to have you all here on board to talk about level measurement in bulk solids, how to effectively monitor inventory in the food and beverage industry. Okay. Just before we get started, I would like to share with you a couple of information regarding the GoToWebinar panel. If you never used it before, you can see on the right side of your screen, there's a small dashboard where you can download this presentation. And you can also type in all your questions and comments in the chat box. By the end of this webinar, we'll have a couple of minutes to answer some of them. If your question is not answered today, we'll come back to you later via email. All right. A brief introduction about myself. My name is Gustavo Queiroz, or simply Gus, and I'm the industry manager responsible for the food and beverage market here in Australia. And today's presentation will be based on the global webinar our colleagues from Germany and the US presented nearly 1 month ago. But we're running a local version to get in contact with you guys and try to be a little bit more close to you. All right, so let's go straight to the point. So before we talk about effectiveness, the first question we must be able to answer is, why do we need to keep an inventory? Well, there are two main reasons. The first one is time. Whenever you place an order, all the material you need won't magically appear in your site to be processed and used. In the real world, there is a significant time between the order and the delivery, and it's very often subject to delays and changes depending on several factors. The second factor is production demand. So you must be able to supply your material based on the fluctuation of your process demand or consumption, which may vary depending on the circumstances. Summarizing, you really need a buffer to keep your process running for long periods of time. Okay, so an effective inventory can truly optimize your supply chain and really avoid delays and unexpected shutdowns. And in today's webinar, we'll really focus on how to keep all the measurements to keep all the measurements and to ensure that you have a very effective inventory system working properly. Okay, so what is behind an optimal inventory management? Well, I have a couple of comments regarding on what we consider an optimal inventory management. And the first one is you must be able to maximize your operational volume at the same time you have to avoid overfills. Okay, you must have a transparent view of your silo measurements, not only for production, but also for order handling and also for your maintenance stuff. All of them must know what's going on with your inventory, not only in terms of production and material available, but also in terms of maintenance, and to really make sure that everything is running the way it should. Okay, and you also have to ensure that you have the right amount of product to supply your demand at all times. At the same time that you have to reduce the risks of manual labor. And this is the approach we consider to be the optimal way for you to control your inventory, to really manage your inventory the proper way. So you have all the instrumentation connected to a telemetry system, sending all this information and gathering into one place for visualization and planning. All right? Cool. So what do I need to consider to really optimize my inventory? The first step on how to optimize your inventory is really to understand your storage conditions. For solids in particular, there are several different sizes, materials, and geometries of silos and bins. And for each one of them, we need to identify the best type of control model, whether by using just a continuous measurement or just by controlling a minimum and maximum level. So you can see, depending on the geometry and on the storage conditions, a continuous measurement is not always applicable. We have to implement a control model just based on limit switches. Okay, so let's try to understand why, and let's go a little bit deeper into these topics. Okay. The second aspect we need to take into account is the kind of product we're monitoring. There's a huge variability of material types, and each one of them has a very unique characteristic. And that's a very big challenge when we're talking about the performance of the sensor, especially in the solid measurements, in the measurement of solids in general. In liquid applications in general, things are a little bit more easy, because since you know, you often know you have a very flat surface regardless of the medium properties. There are some cases where you can have an agitator, you can have a high viscosity fluid, but you can predict how your surface will be. When we talk about solids, this is not really the case. You can have variations in size that ranges, for example, from corn to flowers. You have density variation, you have dust formation, and all of these lead to additional challenges in the measurement. Okay, so let's check a couple of examples and understand what are the general criteria to select the right instrumentation for my silo, for my storage in general. Right? So the general criteria for the instrument selection when we talk about solid measurements. Okay, the first one is safety. Is it a hazardous area? You always have to make sure that you're using the right instrumentation with the right X approval, since many bulk solids are considered flammable. Okay. The second point that we really must keep in mind when we talk about level measurement in solids is to really follow the installation guidelines. The installation must be done in a way that you don't have, or at least you minimize you have the minimum influence as possible of the geometry and the tank filling and emptying dynamics. For example, we need to avoid installing the sensor very close to the filling nozzle. Otherwise, we can get incorrect and very noisy measurements. And in addition to that, the solid dynamics inside the silo can have a filling or emptying cone. So the location and the angle of installation of the sensor is really crucial to have a correct measurements. All right, and the list goes on to the risk of buildup and even the conversion of level to volume and even weight. So there are several aspects we need to have in mind when we talk about when we try to select what is the right instrumentation for my solids, for the solids level measurement. Okay, let's start with the basics then. So the first approach for an effective control, at least from an instrumentation perspective, are the point level switches. There are several types of sensors available that ranges from vibronic sensors, which are these ones here, capacitive sensors, and even non-contact measuring options such as the microwave barriers that can monitor the presence of product through a non-conductive material such as, I know, a polymer or even a glass. All right, so these are very interesting. And what define which one to use? Basically, the installation point and the process conditions. If it's, let's say, oops, sorry about it. If it's a really stressed area, we often try to go with a very robust sensor, such as the capacitive sensors. Okay, and we also have in our portfolio what we call the mechanical pedals, which are a very cost-effective solution. But since you have moving parts, they are more prone to maintenance and damage depending on the process conditions as well. And from an installation perspective, they can all be installed from the side, as you can see here, for minimum or overfill protection, and also on the top of the tank. It depends on the objective behind the instrumentation. Now, moving from the point level switches to the continuous level measurement, we have different types of measurement, and this is really where we can explore the benefits of an effective inventory management. You can see in the picture there are 4 different methods used for a continuous level measurement. 3 of them are based on what we call the TOF, or time of flight measurement. So they all send a small signal, and they wait for the signal to hit the product surface and come back, and it records the time it takes it then calculates the level based on the velocity and the time it takes for the signal to go from the sensor to the product surface. Okay. Historically speaking, the electromechanical was the first technology used, and it's still available until today. It has a weight attached to a measuring tape, and its operation is very close to how a manual measurement is done. So the sensor automatically drops the weight into the sensor until it reaches the product surface, and it records all the distance it has to go through until it reaches the product level. All right. The ultrasonic measurement was for a long time the primary method used for monitor the level of solids, and is still today a very cost-effective solution, especially in very small ranges. But today we'll give a very special focus on the free space radar. Okay, especially because there have been several improvements in the technology regarding the signal processing and different operational procedures that now allow us to use this principle as a reliable resource for level measurement in solids. And in addition to that, we have a guided wave radar used for very specific applications, especially regarding the products, the electric constants. Let's try to understand when to use which one of this from a very practical example. So in this case, for example, if you have flour, sugar, or powders in general, you often have a very light media, which is often the most challenging ones to measure level. This is a type of application where we initially start looking using a free space radars, since it saves a lot of time with a very simple installation. But if we notice that the process conditions are very hard, for example, if you have a very low dielectric constants, or you have a fluidized products where you have a very low density, that's the kind of scenario we are often going for the guided radar, which is the FMP 57. That's the main orientation. So the FMP 57, or the guided radars in general, they have a non-reference. So the instrument always know what is the complete length of its rope. So it always have a reference about where the measurement is. So even if you have a very noisy and dusty application, you always have the right measurement using a guided radar. There are some drawbacks using this kind of technology, because you have to put like a rope inside your silo, and this rope is often exposed to mechanical stress. And you can also, depending on the conditions, you can have the risk of a cable break due to the tension caused by the weight of the material. Okay. Free space radars, depending on the process conditions inside the silo, they can suffer what we call echo loss, especially if you have a very dusty cloud inside the silo. So whenever you send a signal, all of this dust will absorb, and the signal won't be able to reach back to return to the instrument. So we have what we call the echo loss. And in these kind of applications, using a guided radar is really the oriented product to really make sure you have a reliable and effective measurement. And for level detection, pretty straightforward. We always use the vibronic sensors, such as the FTM50, which has a very high sensitivity for very low density. So this is a very, very interesting product to really increase the safety of your operation. Okay. Now that we talked a little bit more about dusty environments, let's talk about the importance of advanced diagnostics. Okay, so why it is so important? You can see on the picture, I don't know, here, this is a free space antenna with a strong build-up. So in general, the free space radars will work normally until the build-up reaches a point where the measuring pulse is nearly totally absorbed on the antenna, and nearly nothing goes to the process. So this is the point where your instrument will stop working. Okay, and this is where the advanced diagnosis really help us. So Endress+Hauser has a concept called heartbeat technology, which is divided in three diagnostic stages, or three pillars, let's say like this. And the first one is a standard diagnostics. So this is where the instrument continuously monitors its operation to make sure everything is doing well. And in case of a warning or failure, it will give you, let's say, a quick and concise remedy to sort the problem out. And all the messages are following a standard called Namur NE 107. So you can really see what's going on with the sensor, and you can effectively correct it once the failure or the message appears in your display. In addition to the diagnostics, we have a second verification, a second diagnostics step, which is called verification. And here you can set up a complete verification on demand. So you need to send a signal or manually start the verification on your device. So the device can evaluate the complete performance and to really check if it's according to the specifications. So the device or the instrument, the level transmitter, will check all internal components to make sure how is the actual condition in comparison to how it was when it left the factory, for example. And from here, you can identify which components are suffering most of the stress during the operation, and you can even predict if one specific component is going to be damaged or not. All right. And the third step of the advanced diagnostics is what we call monitoring. Okay. You can use your instrument to send additional parameters to help you with the predictive maintenance and process optimization. For example, as we can see here, you can send information about the build-up formation in your antenna, so you can do the proper, let's say, a proper intervention before the sensor goes to failure. So the instrument can send you the online information about the build-up you have in your antenna, so you can clean it before it gets you get a failure message from your device. And since we're talking about cleaning and build-up, we also have what we call the airport systems that are available for horn and also for PTFE antennas. And this is one of the main resources we have to minimize the manual labor and consequently the risk of exposure of your staff to the process, and also to extend the performance of your sensor. There's a very nice video that shows how it works. It's here. Hope you guys can see. It's very good. So you can really save a lot of time, especially to keep your sensor's performance during a long period of time, and you don't really need to have someone to cleaning all the antennas in a time-based. So it's a very, very good resource we have for all our level instrumentation. All right. And now, moving from a different scenario, we already talked about very thin particles. Now let's focus a little bit more on larger particle sizes. We can still have dust here, but this is a much better condition to handle compared to very small particle sizes. For these applications, on a continuous level measurement, the free space radar is always the first choice. Okay, so the FMR 67, so which is our 80 gigahertz radar, it can handle all the dust from this very from this kind of material in a very, very easy way. And from a point level detection, both the vibronics or the capacitance switches can also be used, and they're working pretty well. Just one comment regarding the use of limit switches, especially if you have a very high or very tall silos. Whenever you have this installation, especially if you're measuring the, let's say, a minimum level, we always orient you guys to install, let's say, a cover or protection roof, just to make sure that you avoid the direct heat of the material into the sensor's surface. So you can really improve the sensor lifetime just by using protection roof over the sensor. Okay. And here we have a quite impressive application in the second tallest corn silo in the world. And this is a type of application that could have been, let's say, very difficult or even impossible to be done without the use of a 80 gigahertz radar. And why is that? Because we have a very huge measuring area, something around 90 meters. And this was only possible because the new generation of radars has a very focused beam of only 3 degrees. Okay, so if we reduce the measuring angle, we can make sure first that all the energy is really focused and narrowed in one point. And when the signal is coming back to the device, you won't have it, let's say, spread. You don't have a lot of spread to the sides, and you can have a very good signal evaluation after that. So let's see some of the characteristics and the benefits of the 80 gigahertz frequency radar. Okay, so the 80 gigahertz radar is a result of nearly 5 years of development to really deliver a state-of-art radar that can be used both in liquids and also in solids. And since we're able to measure with a more focused and small beam angle, we can take advantage of, for example, the last wall effects. So since we have a very focused beam sent straight to your process, there's way less interference from tank obstacles such as point switches, the geometry of the tank. If you have a very, let's say, different geometry, you can easily adjust the radar or change the position to make sure you have the right targeting area to really do the proper measurement. For example, in the previous radar versions, if you have a very tall nozzle, you usually had to have an increased antenna extension to make sure you won't lose, you didn't lose any kind of energy inside the nozzle. But now with the 80 gigahertz, you can be sure that all the energy will go straight to the place we want it to be, which is the product surface. Okay. And all these factors reflects in let's say, in really time saving, which is much easier with a very simple commissioning and a very reliable measurement signal. All right. So especially when we're talking about solids, this is the second main argument, main reason why the 80 gigahertz is really key for solids applications. So the way the electromagnetic wave interacts with the product at its sloped surfaces depends on the grain size and also on the wavelength of the signal. So if the grain size is in the same range as the wavelength, we can observe what we call a diffuse reflection. So the signal is spread, but we have a very good, let's say, return signal to the device. So we are able to measure it in a very effective and reliable way. So for the 80 gigahertz version, the material size can be something around 4 millimeters. So we can really have a very effective measurement. If we compare it, for example, with the previous versions, not a previous version, but with other radars with different operational frequencies, for example, the 6 gigahertz, which is the first radar we launched to the market, the wavelength is something around 50 millimeters. So you really need to have very large particle size to have a very good reflect signal going back to your device. Okay, so it's the combination of the narrow beam angle with the right frequency that allows us to have a very reliable measurement in solids while using the 80 gigahertz frequency. And here we have another application example, which is for malt grains, in malt silos in general. This is a very simple application for the FMR67 or 80 gigahertz radar. It's pretty easy to handle and it has a very reliable measurement. So all you need to do is just put it there, do the basic commission, and it will work perfectly. And from a point level switch, the FTM50 can really solve all the problems. Okay, so very, very simple and reproducive application where we have a very good installed base all over the world. Okay. Good. So that's a very interesting topic, especially when we talk about level measurement in solids. So when you don't always have very narrow silos. So how do you effectively monitor the level and even convert it to volume if you have very, very large diameter silos? So there are different approaches. There are different ways to solve this kind of problem. The easiest one is to use, let's say, more than one sensor. Usually you need to understand the level close to the tank wall. You usually have to you have to have one sensor installed close to the tank wall, and you have to have another sensor installed close to the center. So like this, you can, based on these two measurements, you can work on the average of your level. So you can send all this information to your PLC or to your control system, and to really do the math and the calculations to see what is the average level. And if you really have like very large silos with several filling nozzles, you can even use more than 2 devices or 3. There are even cases where you can have up to 8 measurements to really understand, let's say, the product surface profile. So these are some of the let's say, of the hints we have if you really have really large diameters. What I do suggest you is to get in contact with our ESEs. They will give you all the support information to understand how many devices you need for your silo, and to define what is the best strategy to really monitor the level in a very accurate way. Okay. Okay. So one alternative we have, if you really want to measure with just one device, we have what we call the alignment accessory or alignment device. So it allows you to install, for example, the radar, you know, 1/4 away from the tank wall, and you can direct the beam to the center of your silo. So you can start working. You can start having, let's say, an average measurement of the level of your silo just by using one device. From my personal experience, having multiple devices spread all over your silo, if you have a very large one, it's usually the best approach, because you can really have very accurate information. You can really understand all the profiling of your tanks. All right, very good. So let's talk a little bit about moisture. So moisture is also a very important parameter when dealing with bulk solids, as it may lead to several operational and quality parameters, such as, you know, clamping. So if you really want to remove or even make sure you have the right moisture level in different steps of our process, we have now incorporated in our portfolio the moisture analyzers that ranges from the portable version. So if you really want to assist your lab analysis by and reduce the load just in the lab, you can now have a portable version to go to several steps of your process and check it manually. But we also have inline versions to really help you to save time and increase your product quality while you're saving resources such as energy, by really having an online measurement of the concentration content. All right. So how do you connect all your inventory data together? How you gather all of them and turn them into useful information? Well, there are several different ways of doing this. So from an Endress+Hauser solution perspective, we can connect either via wired or wireless connection and centralize all this data into a central software called SupplyCare. And from there, you can direct the right information to the right people. For example, your supply chain can check and reorder the materials based on the information you have from your inventory. Okay, your production can program and adjust their process based on the product availability. And if your maintenance staff can check the actual situation of all your devices and act effectively on the problem and really solve them, and all of this in a real time. In all of this in real time. Okay, very good. So just one last slide talking about the actual product portfolio. This is our IO-Link portfolio. We have now incorporated the new detector, which is a level switch with IO-Link, mainly focused for solids, but our IO-Link portfolio is quite broad, ranging from flow meters, which is the picomag, to pressure transmitter, temperature, other kinds of level switches, and even a new sensor we just launched, which is the build-up sensor, used to effectively monitor the build-up in CIP applications. All right, so that's what I really wanted to share with you guys. Now we have some minutes to answer some of your questions. So if you have any question or comment, please just type it in now. We have a couple of minutes to answer some of them. Please just give me a couple of minutes to see how things are going. All right, so we don't have any questions so far. I'll give you 2 to 3 minutes. All right, so if you have one question, just send them now. Just send them now. Otherwise, we can just end our webinar. Okay, so let's give you a couple of seconds. All right, no questions. All right, we have one question. We have 2 questions here. How can we be sure that multiple radar level instruments installed in a grand silo do not interfere with each other? Well, all the measuring signals that our radar send, they're encrypted. So one radar knows what is the, they have like a fingerprint, so they know which is the signal he sent and which signal is coming back, if it belongs to him or not. So that's how our sensors actually works. Is there another question from Oxai? Is there any ability to detect voids or bridging in silos with these devices? Well, this is a very hard situation. Bridging, when you're talking about bridging, is when you have like a small space of air inside your silo, and you can have, for example, an incorrect measurement. So no, we're just talking about level measurement. So all of these need to they're contactless measurements, apart from the electromechanical instrument that I mentioned you. So there's currently no solution to really identify bridging in silos. They all just measure the surface. So that's the current situation we have. You can do it with a load cell, but depending on the silo size, it's usually not feasible for it to have a load cell. Okay. All right, we have some other questions. How do the radars perform in dusty environments? Do we require any auto cleaning of the antenna? Can this be automated by the radar? Yes, if you have a very dusty application, you have a very dusty environment, we often orient you to use what we call the air purge. Okay, The air purge it's easily to be automated with the radar, so you can have like a proper cleaning in regular times to really make sure your sensor is performing the right way, and the dust and the buildup caused by the dust won't affect your measurement. So yes, you can do it. We orient to have the air purge, and yes, you can automate it. This is pretty simple to do it. All right, I'll give you a couple more seconds for the answers. All right. So no more questions. So if you guys don't have any more questions, I guess we can just finish our webinar. So thank you very much for your comments and for being here today with us. I'm pretty sure you download this presentation. If you didn't download, you can do it now, but we'll send you later. You can also have access to the recorded version, and we'll summarize all the questions and send it to you afterwards. Okay, so thank you very much for all of you, and I wish you all a great day.